Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of dot product. So as per the problem, the diagonals of parallelogram are determined by vectors A and B. In part A, we have to show that this parallelogram is a rhombus. So let's start with part A. So a parallelogram is a rhombus if its diagonals are perpendicular to each other. So there's a very important property of rhombus we should understand and memorize. So if vectors A and B are perpendicular to each other, that means this parallelogram is a rhombus. And for that, we'll use the dot product. So the dot product of A and B should be equal to 0 because dot product of perpendicular vectors is equal to 0. So let's start by finding the dot product. Now we can find the dot product by multiplying the x components, y components and z components. So we got 0 for the dot product. That means vectors A and B are perpendicular to each other. Therefore, this parallelogram is a rhombus because its diagonals are perpendicular to each other. So we are done with part A. Now we can analyze part B. Determine vectors representing its sides and then determine the lengths of these sides. So for this part, we should draw this rhombus. So as you may know, in a rhombus, all four sides have equal length. So let's label the corners of this rhombus. So we are given vectors A and B as the diagonals of the parallelogram. We can see that magnitude of vector A is greater than the magnitude of vector B. So if we do the calculation for magnitude of vector A, we get 3 square plus 3 square plus 0 square, and that will be square root of 18. And for B, we'll have to do negative 1 square plus 1 square plus negative 2 square, and that will be square root of 6. So since the magnitude of A is greater, that means the vector A represents the longer diagonal. And the shorter diagonal is vector B. So this is a very important concept we need to understand and memorize about identifying diagonals from given vectors. Now let's assume the side AB is represented by vector X and side AD is represented by vector Y. Now in a rhombus, opposite sides have equal length and are parallel to each other, so side DC can also be represented by vector X. And side BC can be represented by vector Y. So we have to find the vectors X and Y that represents its sides. So for that, we'll have to use the concepts of vector addition. So we are given vector A, and vector A is from A to C. So an alternate way to go from A to C is to go from A to B and then from B to C. And vector AC is equal to vector A, and vector AB is X, and vector BC is Y. And we are given that vector A is equal to 330. So this is our first equation for X and Y. So we can rewrite this as, now we can analyze vector B, which is dB. Vector dB goes from point D to B, and an alternate way to go from D to B is to go from D to A and then from A to B. Now vector dB is the given vector B, and vector dA is the opposite of vector AD, so we can write it as minus vector AD. And vector AB is vector X. Now we can sub in the given vector B, and vector AD is vector Y. Now we can rewrite this equation as, so this is our second equation with vectors X and Y. So we have to use these two equations we got to find vectors X and Y. So now we can write them together. We have to find vectors X and Y. So for that we have to isolate either X or Y from these two equations. So if we add these two equations, vector Y will get cancelled out because one of them has a positive coefficient, the other is negative. And we can add these vectors by adding their x, y, and z components. So 3 plus negative 1 is 2, 3 plus 1 is 4, and 0 plus negative 2 is negative 2. Now we can divide both sides by 2. So we can divide each component by 2, and we get, so this is vector x, and it represents sides AB and DC in the rhombus. Now we have to find vector y, and for that we can sub in this vector x in one of the two equations we got. So we can use this equation here. So we get, now we can move this vector 1, 2, negative 1 to the right side of this equation to isolate vector y. And now we can subtract these two vectors. So we'll subtract their x, y, and z components. 3 minus 1 is 2, 3 minus 2 is 1, and 0 minus negative 1 is positive 1. So this is vector y, and it represents sides AD and BC in this rhombus. Now we also have to find the length of the sides. In a rhombus, all four sides have equal length. So if we find the length of one of its sides, that will be the length for all of its sides. So for that, we can find the magnitude of either vector x or y. So we can use vector x. So for the magnitude, we'll square the components, add them, and apply square root to the sum. So I got square root of 6. This is the length of all sides of this rhombus. So we are done with part B. Now let's analyze part C. Determine the angles in this rhombus. So we can start by finding angle A in this rhombus, because at angle A, vectors AD and AB are arranged in tail-to-tail format. So we can use the dot product equation to find angle A. And our equation will be, so we can use the vectors x and y we found in part B. Now magnitude of vector x is equal to square root 6, and magnitude of vector y is also square root 6 because all sides have the same length. Now we can do the dot product on the left side. We can multiply the x, y, and z components. 1 times 2 is 2, and 2 times 1 is 2, and negative 1 times 1 is negative 1. And square root of 6 times square root of 6 is 6. On the left side, now we can combine the numbers. I got 3. So cos A is equal to 1 over 2. Now we can do the inverse of cos. So A is equal to 60 degrees. So that's the measure of angle A. Now in a rhombus, opposite angles have the equal measure. So that means angle C is also equal to 60 degrees. And in a rhombus, adjacent angles are supplementary angles. That means their sum is equal to 180 degrees. So the measure of angle B will be equal to 180 degrees minus 60 degrees, which is equal to 120 degrees. And angle D is equal to angle B because they are opposite angles. So angle D is also equal to 120 degrees. So these are the angles in this rhombus. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.